Good evening, sir.
Yeah, ma'am. Good evening, ma'am.
Yeah, sir, you can start, sir.
No, I'm not able to share the screen, ma'am.
Yeah, I'll do that. I'll make you as a host, sir. Yes, sir, you can continue, sir.
Okay. Good evening, students.
Good evening, sir.
Yeah, good evening. So we'll do more today, possibly one derivation, and then we will start with a lot of numericals. Pay attention. Yesterday we learned with the packing efficiency of simple cubic cell and face-centered cubic cell. What's the packing efficiency in simple cubic lattice? It is 52.4%, and in case of face-centered cubic lattice, it is 74%. We learned yesterday. So we will be learning with respect to body-centered cubic structure now. Now, in order to understand the body-centered cubic structure, first let me draw the cube. Pay attention when I'm drawing the cube, and I'll explain this. Mhm. This is a cube, right? This is a cube, and all the corners you have a particle. I'm representing it by blue. All the corners there is particles. Now we are talking about a body-centered cubic structure. In order to understand the body-centered cubic structure, you should know there is a particle at the center also. There's a particle at the center of the cube. And I'm also representing one more for our representation. I'm representing a face-centered atom also, like this here. Face-centered atom. Now this I mark it as A and C. This I mark it as A and C. This is B. Now we have one triangle you can observe, that is A, B, and C. Triangle ABC. Is it possible for you to understand A, B, and C? There's a triangle. Yes?
Yes, sir.
Yes, sir.
Now this I mark it as D. Now D is passing through the particle which is at the center and passing through A. This D is passing through the particle which is at the center and touching A. This is another straight line. You should visualize that. From D, there's a straight line which is touching the particle, body-centered particle, and touching A. So now you have to understand one more triangle, that is A, D, and C. A, D, and C. A, D, and C. Is it possible? Possible? Can you see two triangles? One is A, B, and C. The other one is A, D, and C. Are you able to visualize that? Can you see that?
Yes,
Yes,
sir.
sir.
Now, if you have understood this cube, then it is easy for us to derive. Now, before we go for the derivation, now there is a particle at D. I'm representing this as D. And this is the particle which is at the center of the body. And I'm representing this particle again, A, here. This is nothing but A. This is D. This is the particle at the body center, and this is A. So I've represented like this. This is the center of the particles. Now, what will be this length? Can anyone tell me what will be this length?
Age length?
Yeah, what is this value? What will be the value? AD? What will be AD? Can it be 4R? This is the radius of the sphere. This is the radius, another radius. This is the diameter, and this is the radius. So AD will be equal to 4R. Is it understandable? This is the radius R. Here it is R, this is R, and this is also R. Did you understand this?
Yes, sir.
This A is a corner atom. D is also a corner atom. And this is a body-centered atom. There should not be any confusion. Now we have learned two triangles here. One is ABC. The other one is what? A, D, and C. Now we will get into the derivation of the packing efficiency of body-centered cubic structure. Now, if you observe in this figure, the spheres at the body diagonal are touching each other. What is the statement? You understand? In this figure, the sphere at the body diagonal are touching each other. It means the particle which is at the center, that is this, is touching the particle A and what? Particle D. That is what it means. Is it understandable? In this figure, the spheres at the body diagonal are touching each other. Clear? Therefore, we can say AD is equal to how many R now? 4R. We found out here. I explained it clearly. Yes or no?
Yes, sir.
Please participate. Yes?
Yes, sir.
Yes, sir.
Now from the triangle ABC, now can I write AC from the triangle ABC? Can I write AC square is equal to AB square plus AC square? Can I write Pythagoras theorem? Yes or no? This AC square will be equal to AB square plus what? BC square. Students, are you following?
Yes, sir.
Yes, sir.
Now, what is the edge length? Normally, we represent edge length by what? Letter A.
A.
AC square will be equal to A square plus what? A square. Or AC will be equal to square root of A square plus A square. Or we can write AC as what? That will be equal to the square root of 2A square. Or we can write it as what? Root 2A. Is it possible? Can we write it as root 2A?
Yes, sir.
Yes. This is from the triangle ABC. Why do we want this value AC? Because if I'm considering the triangle A, D, and C, I should know what is this length. What is this value? AC. That is why we have considered this ABC first. All right. Now from the triangle ADC, from the triangle ADC, what will be AD square? What will be AD square? AD square will be what? AC square plus
DC square.
TC square. Very good. AC square plus TC square. So it will be AC square plus DC square. What is AC? AC we found it as what? Root 2A. So root 2A the whole square plus what is DC? DC also should be what? Edge length only, no? A.
Yes, sir. Yes, sir.
A. Therefore, one minute, sorry. Therefore, it will be what? A square. This is AD square. So again, AD square will be equal to, what is this? Root 2A square will be what? 2A square. 2A square plus A square. Yes or no?
Yes, sir.
That will be equal to what now? AD square will be equal to 3A square. What will be AD now? AD will be equal to square root of 3A.
3 into A.
3A. 3A. Ashtedane. I mean, see, 3A. Correct. If I take root, this will get cancelled. Root 3A. So therefore, we can write 4R is equal to what?
Root 3 into A.
Root 3 into A. Okay, root 3 into A, like this. Okay, root 3 into A. Because we know that AD is what now? 4R. 4R. So we can write 4R is equal to root 3 into A. So what will be A? A will be equal to 4R
4R by root 3.
3,
Root 3.
or we can write R is equal to root 3A by what? 4. Root 3 into A by 4. So this is the edge length. This relation also you should know. This is the relation. A is equal to 4R by root 3A, or R is equal to root 3A by 4. Out the problems. Later we will be working out the problems. So the next part of the derivation, I will do it here only. Once you know that, what is the volume of the unit cell now? Volume of the unit cell. The volume of the unit cell is nothing but A cube. Now, how much we found out A as? A we found out as 4R by root 3. So that will be equal to 4R by root 3 the whole cube. So 4R by root 3 the whole cube will be
64R root cube
by 3 root
3.
by root 3. By root 3. 3 root 3, no? By 3 root 3, right?
Yes, sir.
Yes. Now, what will be the number of particles in BCC? Number of particles in BCC, body centered cubic lattice. In face centered, it was 4. In simple cubic lattice, contribution is what? 1. In body centered, I told you it is 2. Now tell me, how do I find the packing efficiency? Packing efficiency, how do I find? What is the formula to calculate the packing efficiency? Yesterday we did 2 derivations. Packing efficiency.
Volume of the sphere by
Volume of the sphere
cube.
Volume of the sphere by
Volume divided by volume of the cube.
Volume of the cube or volume of the unit cell. Volume of the unit cell. All right. So volume of the sphere is what? 4 by 3 pi r cube. I have not written it properly. You understand. It's 4 by 3 pi r cube. But since it is body center cube, I should multiply it by what? 2, because each body center contribution is what? 2. Divided by what is the volume of this unit cell. Now we found out volume of the unit cell is 64 r cube by 3 root 3. 64 r cube by 3 root 3. If you simplify this, you will get the value to be 0.68. That is 68%. That is 68%. You can simplify it. So the value or the packing efficiency of a body-centered cubic lattice is 68%. What is the free space? The free space will be around 32%. But anyways, now one more time I'll explain. So this is a cube. It's a lengthy derivation, a lot of mathematics involved. Okay, this is a cube in which there is a particle at the center of the cube. Now we are considering 2 triangles, A, B, and C, and also we are considering A, D, and C. Now in case of A and D, this particle which is at the center, the particle which is at the center is touching both the particles in the corner. Therefore, we are writing it as what? This is a corner atom D, this is a corner atom A, and this is a body center atom. So the edge length or the distance between A and D will be equal to 4R. This is the understanding. Now AD is what? 4R. From this, we can start our derivation. Consider the triangle ABC. ABC is AC square plus AB square plus AC square. We have learned that AC square will be equal to square root of A square plus A square. That is square root of 2A square. That is root 2A. That is root 2 into A. Now, from the triangle ADC, we know that AD square is equal to AC square plus DC square. Again, complete simplification. You get AD is equal to root 3A. AD, we know that it is 4R. 4R is equal to root 3A. Since we know that 4R is equal to root 3A, we can write A is equal to 4R by root 3, or we can write R is equal to root 3A by 4. Now, this is what we require because we need to find the volume of the unit cell. Therefore, this value A we require. What is the volume of the unit cell? The volume of the unit cell is given by the formula A cube. That is 4R by root 3, the whole cube. So on simplification, you get the value 64R cube by 3 root 3. 64R by R cube by 3 root 3. This is the volume of the unit cell of body-centered cubic lattice. Now, packing efficiency is given by the formula volume of the sphere divided by volume of the unit cell. Volume of the sphere is 4 by 3 pi r cube into 2, because the contribution of body-centered particle is 2 divided by 64 r cube by 3 root 3. It gives you 0.68. It is nothing but 68%. The packing efficiency in body-centered cubic lattice is 68%. All right. Did you understand this derivation? No response.
Yes, sir.
Nobody is there to respond, only accepting 2 students. Huh?
Yes, sir.
Yes, sir.
Now, this tabular column you observe. This tabular column you observe. This is simple cube, body-centered cube, face-centered cube, HCP, and this DC you don't have to worry. Okay, maybe you can remember with respect to hexagonal closed packing arrangement, but this you don't have to worry, diagonal closed packing. The number of atoms per unit cell. What's the contribution of simple cubic lattice? It's 1, body-centered is 2, face-centered is 4. Now, coordination number of simple cube is 6, body-centered cubic lattice is 8, and face-centered cubic lattice is 12. Packing efficiency or packing fraction, or it is also called as packing efficiency, 52% in simple cube, 68% in body-centered, 74% in face-centered, and even hexagonal closed packing is 74%. This is important to work out more problems. This is important. These relationships are very important. Now, for a simple cubic lattice, what is the atomic radius? R is equal to A by 2. For body-centered cubic lattice, R is equal to root 3A by 4. Likewise, for face-centered cubic lattice, R is equal to A root 2 by 4. These formulas you should remember. For face-centered, what is the relation? R is equal to A by root A root 2 by 4. Otherwise, we can also, we can write it as what? We can write it as A by 2 root 2 also you can write. Can we write this? A root 2 by 4, can we write it as A by 2 root 2? Can we write or not? If you have R is equal to A root 2 by 4, can we write it as A by 2 root 2? So multiply this by root 2 and multiply this also by root 2. What happens? What happens? Root 2 into root 2 is how much? Root 2 into root 2 is how much?
Root to the whole square.
Whole square is what?
So
2,
2.
sir.
2.
So what happens? So this 4 will get cancelled. No, 4 and 2 will get cancelled. So what you'll get? You'll get 2 root 2 only. Did you understand? Maybe I'll
Yes,
write
sir.
it again. I have 1 minute. The simple mathematics is. All right. So R is equal to A root 2 by 4. So multiply this also root 2, multiply the denominator also by root 2. What happens? You will get R is equal to A 2 by 4 root 2. Now, if you cancel this, what happens? You get R is equal to A by 2 root 2. Correct? So this formula you should remember. Either ways, it is useful to calculate either the radius or either the edge length. This formula you should remember. And volume of a unit cell or volume of a sphere, you know it is A cube. Example for simple cubic lattice polonium, body-centered cubic lattice sodium, lithium, chromium. They have given so many examples. This tabular column also you can remember to work out the problems later. Now, the next part of the topic here is to calculate the density. We know that density is mass by volume. Density is mass by volume. So here, density is mass of the unit cell divided by volume of the unit cell. So how do you find the mass of the unit cell? The mass of the unit cell is given by the formula Zm by Na. Z is effective number of atoms in the unit cell. M is the molar mass. Na is the Avogadro's number. What is this Z here? Z is the effective number of atoms in the unit cell. Z in case of simple cubic lattice is 1. Remember, Z in body-centered cubic lattice is 2. Z is nothing but number of unit cells, particles in the unit cell. Z in FCC is equal to how much? 4. Don't get confused. Z is nothing but the number of particles in the unit cell of the simple cubic light. It is 1. In case of body center, it is 2. In case of face center, it is 4. So mass of the unit cell is given by the formula Zm by Na. You should know the molar mass. Now, if I ask you to find the density of sodium chloride, what will be the molar mass of sodium chloride? You should be in a position to find out.
53.5.
Atomic mass of sodium is 23 and chlorine is what, 35.5. So it will be 58.5. You should know how to find the molecular mass. We will learn about that a little later. Now, this is the formula to calculate the mass of unit cells, Zm by Na. Once you understand that, density is now Zm by Na. This is the mass of the unit cell, and volume of the unit cell is given by the formula what? Aq. Therefore, density becomes what? Zm divided by Na into what? Aq. This is the formula to calculate what? This is the formula to calculate what? The density. What will be the unit for density? Density will be what? Gram per centimeter cube. Gram per what? Centimeter cube. Did you follow this?
Yes, sir.
Yes,
So
sir.
we'll work out some of the problems based on these questions. Let us see the simple problems I'll give you. Before that, we'll work some problems which I've typed and kept for you. Now, calcium crystallizes in FCC unit cell. Calcium crystallizes in FCC unit cell. When the edge length of calcium is 0.556 nanometers, they have given us 0.556 nanometers. Calculate the density of the crystal. Calculate the density of the crystal. Now, 1 nanometer is equal to how many meters? 1 nanometer is equal to how many meter?
10 power minus 9.
10 to the power minus 9 meter. They have given 5.556 nanometer. So density, we learned it, unit for density as what? Gram per centimeter cube. That means we have to convert the nanometer in centimeters. So in order to convert the nanometers in centimeters, see here, maybe I'll write here, 1 nanometer is equal to 10 to the power minus 9 meter. Therefore, 0.556 nanometer will be equal to how much? It will be 0.556 into what?
10 power minus 9.
10 to the power minus 9 what? 10 to the power minus 9 what? Meters.
Meter.
But we want it in centimeters. How do I convert into centimeter? We know that 1 meter is equal to how many centimeter? 100 centimeter. 100 centimeter is nothing but 10 squares. So 0.556 into 10 to the power minus 9 into 10 to the power what? 2. That will be equal to how much? 0.556 into 10 to the power minus 7 centimeters. Did you understand? Conversion, did you understand? 1 meter is 100 centimeters. So 0.556 into 10 to the power minus 9 will be what? Cross multiplication. If I have to write completely, it will be 0.556 into 10 to the power minus 9 into 10 to the power 2 divided by what? 1. That will be giving you this value. So it will be 0.556 into 10 to the power minus 7 centimeters. Did you follow this?
Yes, sir.
So A you have calculated. Now they say calcium crystallizes in FCC. So if it is crystallizing in FCC, what will be Z value?
4.
4. Now what will be the molar mass? Molar mass or no,
40.
calcium, we cannot talk about molar mass. Calcium is an atom. So what's the atomic mass of calcium? The atomic mass of calcium is 40. Now we will take it in terms of what? Grams. Now tell me what is the formula to calculate density. Density is given by the formula Z into M divided by Na into A cube. So now what is Z? Z is 4. M is what? 40 divided by what is Na? Na is 6.023 into 10 to the power 23. Avogadro's number 2 into 10 to the power 23 into what is the A value? A value is 0.5
0.55 into 10 to the power of minus 7.
7. The whole
3.
because volume is what? A cube. So 0.556 into 10 to the power minus 7 the whole cube. Now on simplification, I think you can simplify this. Students, you can simplify this. I'll give the final answer.
Okay.
Minus 7 into 3 is minus 21. 0.556 into 3 times you can multiply. So minus 21 and 23, it gets what, 10 to the power 2. Is it possible for you to simplify at home? So the value
Yes,
what
sir.
you get is
Yes, sir.
1.546 gram per centimeter cube. Therefore, the answer for this question is option A. Do you follow this?
Yes, sir.
Yes. Just observe. Simplification, you have to work. Mathematics part of it, you have to work at home when you're free. The next question, these recordings are there. You can watch anytime and work out. Now, chromium metal crystallizes in BCC. Chromium metal crystallizes in BCC. The edge length of the unit cell is in picometers. Picometers is 287 picometers they have given. And they have given BCC. Now BCC, the number of particles in the unit cell of BCC is
Two.
equal to how much?
2.
2.
We want radius. They given radius in terms of what? They've given what's that? They've given the edge length in terms of what? Picometer.
Meter.
Picometers. So now they're asking you to calculate what? The atomic radius. They're asking you only to calculate the atomic radius. So for BCC lattice, what's the relationship? What's the relationship between the radius and the edge?
R equals to
R is equal to
root 3a by 4.
4. This formula, this chart you should remember. All right. So R is equal to what now? R is equal to root 3a by 4. So root 3, what is A? They have given 287 picometers. 287 picometers. But on simplification, you get 124.27 picometers. On simplification, root 3, if you simplify it by 1.4 or something, you simplify and then you can multiply it by 287 divided by 4. So you will get 124.27 picometers. Hence, the answer for this question is option B. Option B. Now you tell me, can we continue this question? Can I further continue this question and ask you to calculate the density? So density will be what now? For this, I have not asked, but I'm giving you. Density will be what? Zm by Na into A cube. So here Z is what? 2 molecular mass of what? Chromium. Atomic mass of chromium, you should remember. They will give you. It is 52. Atomic mass of chromium is 52. And Avogadro number, it is 6.02 to the power 23. And what is this value? You should tell me. I want you to understand. They've given the edge length A to be 287 picometers. What is the unit for density? What's the unit for density?
Gram per centimeter cube.
Gram per centimeter cube. Can I take this value then? Can I take 287 picometers then directly? I have to convert this into convert it into centimeters. How do I convert it into centimeter? 1 picometer is equal to how many meters? 1 picometer
minus 12.
Minus 12 meters. So 1 picometer is equal to 10 to the power. How many centimeters then? 10 to the power?
Minus 10.
Minus 10 centimeters. So 287 picometers will be how much now? So it will be 287 into what? 10 to the power minus 10 centimeters. Do you understand? See, 2 questions we solved. In the earlier question, they've given the edge length in terms of nanometers. We learned how to convert it into what? Centimeter. Here in this question, they're giving the value in terms of what? Picometers. So we need to convert the picometer into what? Centimeter. So conversion factor I gave you here. 1 picometer is 10 to the power minus 12. Was 1 picometer is 10 to the power minus 12 centimeters, 12 meters. So therefore 1 picometer is 10 to the power minus 10 centimeters. So 287 picometers will be how much? 287 into 10 to the power minus 10 centimeter. So this will be 287 into 10 to the power minus 10, the whole cube. Because the value for A is what? The volume is what? A cube. On simplification, you will get the value 7.3 gram per centimeter cube. So this was not in the question, but I wanted you to understand this, how to convert picometers into centimeters. So this question also is possible. This type of question also can ask. They can ask you radius as well as they can ask you to calculate what? Density. All right. Both in the options they can give 124.27 and they can give you 7.3 gram per centimeter cube. So they can ask you to calculate both. So you should be in a position to work out the problems. Followed with these two questions, what we learned? Followed with these two questions?
Yes, sir.
Yes,
Sir.
The third question similar question, we'll work a few questions based on density, and then we'll go calculation of radius, edge length, all that little later. Now, lithium borohydride or lithium boron hydride, we can call this also lithium boron hydride, LiBH4. So LiBH4, it's a very good reducing agent. Lithium aluminum hydride, lithium boron hydride, they're all very good reducing agents. They crystallizes in orthorhombic system. They crystallizes in orthorhombic system with 4 molecules per unit cell. What do you mean by that? It is not crystallizing in FCC. If it crystallizes in FCC, we know the number of molecules, that is 4. But it is an orthorhombic system. We are not learning orthorhombic system. So they have given you in the question the number of molecules per unit cell. So Z value they have given us what? 4. The unit dimensions are A, they have given as 6.81 angstrom unit. This is how we represent. And B, they have given 4.43 angstrom unit. And C, they have given 7. It is not 717, it is 7.17. It should be 7.17. 7.17 it is. 7.17 angstrom unit. There is 7.17 angstrom unit. All right. And the molar mass they were given for lithium boron hydride, molar mass they were given 21.76 gram per mole. And they're asking you to calculate the density. They're asking you to calculate the density, rho. Now, how do you calculate this? Now, what is this A? A is what? The length. B is the height. And C is what? The width. ABC. 1 angstrom unit is equal to how many meters?
10.
10 to the power?
10 minus 10.
Minus 10. Minus 10. So 1 angstrom unit is equal to how many centimeters? How many centimeters? 10 to the power?
10 to the power of minus 8.
Minus 8 centimeters. You should know this conversion factor. Now you tell me, what is density? Density is equal to Zm by Na into what? A cube. So Z we know it's given as 4 and M they have given 21.76. Na is 6.022 into 10 power 23 Avogadro's number. Now what is this A cube? What is this A cube? Can I write 6.81 into 4.43 into 7.17 into 10 to the power minus 8 the whole cube? Can we write like this?
Yes, sir.
Yes. On simplification, you simplify and check whether the answer is right. On simplification, you will get the value 0.668 gram per centimeter cube. So answer for this question is option B. I'm not doing the mathematics part of it. I want you to work it out. And you know why I've taken that 6.81 into 4.43 into 7.17? Because we know the volume is A cube. It is not uniform here. So volume will be what now? A into B into C. Volume of the unit cell will be what? A into B into C. That is why 6.81 into 4.43 into 7.17 into 10 to the power minus 8 the whole cube. Followed with this?
Yes,
Yes,
sir.
sir.
Now the next question. Copper metal has face-centered cubic structure. Copper metal has face-centered cubic structure with a unit cell length of 0.361 unit cell length. That means they've given you A as 0.361 nanometer. They're given 0.361 nanometers. In the options, I should have typed nanometers. I didn't do it yesterday. Maybe this is nanometers. Picturing copper ion in contact along with the face diagonal, the apparent radius of copper ion. What is that? Picturing the copper ion in contact with the face diagonal. So that means copper is at the center, and there is one more at the corner here, and there's another corner. They're asking you to calculate the radius of copper. They're asking you to calculate the radius of copper. I will redraw. This is copper. This is the particle at the edge, and here this is another particle. So they're asking you to calculate the radius of what? Copper. Now, how it is related? It's a face-centered cubic lattice. We know that radius is equal to root 2a by 4. There's a chart, we learned the chart. See, root 2a by 4. Root 2a by 4 or a root 2 by 4. It's all the same. This is for face-centered cubic lattice. This is very important. This relationship you have to memorize and remember. So root 2a. Now this is root 2. A, they have given it nanometers. And the answer is also in nanometers. Since the answer is also in nanometers, so you can directly use at 0.631. No conversion required. Divided by, what is that? 4. When you divide this by 4, you will get 0.128 nanometer. Radius is 0.128 nanometer. So you can simplify. Root 2 is 1.4, I think. Simplify and check. So you will get 0.128 nanometers. The answer is option. This is a simple problem. Relations only you have to memorize or remember. Otherwise, it will be difficult. You will go wrong. The next question. Xenon crystallizes in FCC. Again, the same formula. Xenon crystallizes in FCC. The edge length of the unit cell, they've given edge length of the unit cell as 620 picometers. They're asking you to calculate the radius. What is the formula? R is equal to root 2a divided by 4. Now, do I have to convert this into centimeters? You look at the options. All the options they have given in picometers only. So not necessary to convert. It will be root 2 into 620 divided by 4 on simplification. You will get 219.20 picometers. You'll get 219.20 picometers. Therefore, the answer for this question is where? Where's this? The option A, the first option. It's a direct substitution, yes or no?
Yes, sir.
See, sometimes don't get confused. This relation, you can also use R is equal to A by 2 root 2. It's all the same. Both are same or not? This both formula. Yes. So sometime in textbooks, they would have given this this formula also. Anything is same. Both represent what? Same. You will get the same answer. Clear? Is this, boys, students, is the same? I explained it.
Yes, sir.
R is equal to root 2a by 4. If I multiply and divide it by root 2, you will get 2a by 4 root 2. So this will get cancelled. Therefore, it will be what? A by
root 2.
Both are same. You can use any of the formulas. You should remember so that you can work out the problem. The next problem, the edge length of a cube is 400 picometers. The edge length of a cube is 400 picometers. A is 400 picometers. The body diagonal would be, what is the body diagonal? This is for what? A cube, its body diagonal would be. When I say body diagonal would be, let us see. Can I call this as body diagonal? Can I call this as body diagonal?
Yes, sir.
Diagonal is what? AD. What is AD? What is AD? AD, are we getting root 3a? Can you observe this? Root 3a?
Yes, sir.
Yes, this is what body diagonal means. See, these all are the formulas which you have to remember in this chapter. So it is confusing. But if you practice, you will remember. Body diagonal is what now? Root 3a. For body-centered cubic lattice, the body diagonal is root 3a. So it will be root 3 into 400. So on simplification, you will get the value to be around
Sir,
6.
option C.
Very good. Option C. Very good. It is option C. 693 picometers. Give me a minute time. Okay, next problem. Next problem. Students, did you follow this?
Yes, sir.
Yes, sir.
Another 1 or 2 classes, we should finish this chapter. All right. Now, at 4,425 degrees Celsius, iron crystallizes in BCC lattice. Iron crystallizes in BCC lattice, whose edge length is 293 angstrom. Edge length A is what? 293 angstrom unit. Assuming the atom to be packed spheres, calculate the radius of the sphere. Calculate the radius of the sphere. It is a body-centered cubic lattice. What is the relation? Body-centered cubic lattice, R is equal to root
3a by 4.
of 4. So it's a direct substitution, root 3 into, see, answers they have given in angstrom unit only. So need not to convert this. So it will be 293 divided by 4. On simplification, you will get it as 1.208 angstrom unit. 1.208 angstrom unit. It's a simple mathematics, this is. So the answer for this question is option A, 1.208. Next question. Cesium chloride, crystalline cubic structure of ions in which cesium ion is present at the body center. If the density is 3.99 gram per centimeter cube, calculate the length of the edge of the unit cell. Calculate the length of the edge of the unit cell. Calculate the length of the edge of the unit cell. What is the length of the edge of the unit cell? Now, can I say cesium chloride has a cubic structure of ions in which cesium ion is present in the body center? All right. If the density is 3.99, calculate the edge length. Now we know density is equal to Zm by what? Na into A cube. Now, is it possible for us to calculate Z? What is Z now? Z. Cesium chloride has a cubic structure, and they say in which cesium ion is present in the center, body center. So now in case of BCC, Z value will be 2. Z value will be how much?
2.
2.
Z value will be 2. But they are talking about what? The edge length. They are asking you to calculate edge length. So in order to calculate edge length, we will consider one cesium ion and what? One chloride ion. Therefore, we will consider Z to be 1 in this case. You know why I'm considering Z to be 1? Because they're asking you to calculate the edge length. So one cesium ion and one chloride ion has to be considered. So we'll take Z to be 1. When Z is to be 1, what I can write? A cube will be equal to what? A cube will be equal to what? Zm by density into what? Na. Now, what is Z? Z is 1. What is the mass of cesium chloride? The mass of cesium chloride is 168.5. This you should remember, or they'll give you in the question. The atomic mass of cesium and the atomic mass of chlorine they will give you. It is 168.5 divided by density they've given. What is the density they've given? 3.99 into Avogadro number 6.022 into 10 to the power 23. So on simplification, you will get A to be 4.123 into 10 to the power minus 8 centimeter. 4.123 into 10 to the power minus 8 centimeter. But answers are in picometers. How do I convert it into picometers? That will be equal to what? 412 into 10 to the power minus 12 meters. That will be equal to 412 picometers. The answer for this question is option A. Did you follow this answer?
Yes, sir.
Yes, sir.
Follow the working. Work out the mathematics part of it. Mathematics part of it should be right. All right. Let us see the next problem. A metal, oh, there is no space here. Okay, I'll try to write it here only. A metal crystallizes in 2 cubic phases, FCC and BCC, whose unit length is 3.5 and 3 angstrom respectively. So for FCC, the unit cell is whose unit length is 3.5, and for BCC it is what, 3 angstrom respectively. Calculate the ratio of densities of FCC and BCC. Calculate the ratio of densities of FCC and BCC. So first they have given FCC. So density of FCC will be equal to what now? We'll write Z1 into M, because a metal remains same in both the cases, FCC and CCM, divided by Na into V1. Now density of BCC, what it will be? It will be Z2 representation, that's all, Z1, Z2. And mass remains the same, divided by Na into V2. So if I divide density of FCC by density of BCC, what do I get? I get value Z1 divided by Z2 into what? V2 divided by V1. Correct. What is that they've given? They've given they've given what? A for what? FCC, and they've given A for what? BCC. So that will be equal to, Z is what for FCC? 4. For BCC, it is what? 2. What is V? What is V2? What is V2? Since we are talking about density, we need to convert this into what? Centimeter inverse. So it will be, this is V2. V2 is what? 3.0 into 10 to the power minus 8 the whole cube. Correct? Correct? It is V2 by V1. You know, should I do the mathematics part of it also here? So if I divide Z1 M by Na into V1 divided by Z2 M divided by Na into V2, what happens? This M and this M will get cancelled. This Na and this Na will get cancelled. So what you will get? Z1 by Z2 will be equal to what now? This V2 will go where? Numerator. So it will be V2 by V1. Yes or no?
Yes, sir.
Yes. Now what is the volume? V2 is what? 3. 3 into 10 to the power minus 8. We have to convert it into centimeter inverse. They have given it to angstrom unit, convert it into centimeter inverse. Divided by 3.5 into 10 to the power minus 8 the whole cube again. So on simplification, you will get the value to be 1.259. The answer for this question is option A, 1.259.
Sir,
Yes.
one doubt is, sir.
Tell me.
Sir, Z1 into M divided by Avogadro numbers into A power 3 ಬರ್ಬೇಕಲ್ವಾ sir? ಅದೇಂಗ್ sir?
How do you know Kannada, man? From where you're talking? Eh? Good. Tell me your clarification. A cube, you should get A cube. A cube is
Yes,
nothing
sir.
but what? Volume only, no? A cube is what? Volume only, no? Length into breadth into height is what? Volume only, right? That is why I've
Yes,
written as
sir.
V1. That is why I've written as V1. You can write it as A cube directly here. You can write it as directly A cube. So it'd be, maybe we can write it as what? Very good. You can write it as A1 cube here. You can write it as what? A2 cube. So it'll be what now? A2 cube here. And this is what? A1 cube. Fine. That's fine. All the same. Correct?
Yes, sir.
It's A cube is nothing but what? Volume only, no? So I have written it as what? V1 and V2. You can take it as what? A1 cube and what? A2 cube. Fine. That's also fine. You'll get the same answer. Very good. What's your name? What's your name? Okay. Don't want to tell your name.
She is
All right.
Kavya, sir.
Kavya. From Bangalore, huh?
Yes, sir.
Okay, good. So the next problem, a solid AB has sodium chloride structure. If radius of cation A plus is 120 picometer, if the radius of cation is 120 picometers, calculate the maximum value for radius of the anion. So this formula is based on something called as radius ratio. Now they say a solid AB has sodium chloride structure. Sodium chloride has octahedral structure. Sodium chloride has what structure? Octahedral structure. Now, since sodium chloride has octahedral structure, if you remember, we have learned radius ratio. I will show you, yeah, this tabular column. This is important. See, octahedral, the coordination number is 6. The range is what? 0.414 to 0.732. So in order to see, this tabular column is also a must. You should remember this radius ratio, coordination number, and few examples so that you can work out the problems. So here in this case, for octahedral, it is 0.414 to 0.732. This is the range. So if the radius ratio range falls in this, then the coordination number is 6, and the type of the structure of the solid is what? Octahedral. Now here the question what they have asked. Where's that question? Yeah, where's that? All right, they've asked here a solid AB as NaCl structure. If the radius of what? A plus is 120 picometer, calculate the maximum value for the radius of the anion. So we can write radius of cation by radius of anion P minus is equal to the radius ratio, is equal to radius ratio. This is the formula. This is radius ratio. Now, they have given you, it is an octahedral structure, sodium chloride structure, and the range we know it is 0.414. You should always take the minimum. You should always take the minimum. So what will be the radius of the anion now? Radius of the anion will be equal to radius of the cation, this is plus, right? Cation by 0.414. Radius of the cation they've given us 120 picometers divided by 0.414. You will get this value to be 290 picometers. You will get the value to be 290 picometers. It's option A. All right. Can we continue, ma'am? Can I continue the class next session? Next part of the topic and problems? Yes? Hello? Ma'am, can I continue the class?
Your wish.
Yeah, ma'am. Yeah, ma'am. It's all. We'll continue the next class, ma'am. Thank you.
Yes, sir. Yes, sir. Thank you, sir.
Bye.